Hello YouTube, welcome to BPS Expert. In today's video, we are going to look about oxidation. In the world of chemistry, there are two reactions plays a major role in the formation of chemical compound. One is oxidation, the other is reduction. Oxidation refers to the loss of electron and reduction to the gain of electron. Though it's a gain process, it was called reduction because there is a reduction in the oxidation number of an atom. Let me see about oxidation number. The oxidation number refers to the number of electrons that gained or losses during the chemical formation of an atom. If an atom loses an electron, then its number became +1. If it gains, then it becomes -1. Depending on the number of electrons that it gain or loss, its numbers may vary. Let me see an example. The formation of methyl CH3, the carbon atom undergoes the oxidation state -3 by gaining 3 electrons, and the hydrogen undergoes +1 by losing 1 electron. The electrons that are present in the outermost layer of the atom are responsible for this oxidation state. Let me find out this the simple Python programming. Before getting into that, you may find out that the number of electrons that are present in the outermost shell or the whole shell of an atom. From our school grade, we all know a formula that to find the number of electrons that are present in the shell, which is 2n square. So here in my case, the n refers to the fourth, which means the fourth orbital of an atom. So the number of electrons that are present in the fourth orbital is 32. If it is 2, then the number of electrons present in the second orbital is 8. Here I am giving an input, a number, but how much electrons are present in an atom that I want. So in my case is 7, where the atomic number of 7 refers to the nitrogen. So let's see. So nitrogen has 2 shells. The first shell, normally first shell has 2 electrons and the second shell has 8 electrons. Let me find that the number of electrons is present in the last shell of a same nitrogen atom. So I'm giving a 7 again. There are 5 electron presence, which means in the place of 8 electrons, there are only 5 electrons present. So these 5 electrons and the remaining 3 electrons are responsible for the oxidation state of a nitrogen. So we can look here that +5 to -3. We'll be back. We all know that those 5 electrons are present in the suborbitals of this second shell. What are the suborbitals? There are lots of suborbitals in an atom. So they are S, P, D, F. We know it from the school grades. Here, the S orbital has 2 electrons, and the P orbital has a total of 6 electrons, and the D orbital has a total of 10 electrons, and the F orbital has a total of 14 electrons. And in those orbitals, the electrons are present by pair. For S orbital, there are 2 combined by pair, and for P, it's 3, and for D, it's 5, and for F, it's totally of 7 pairs. So here I made a code to find out the suborbitals that electron presence. So this is the code to find that electrons in suborbitals. Okay. Now I am running this program. So again, in my case, it's of 7. And you can find that the 5 electrons are present by 2 in s and 3 in p orbitals. So if you check out for some other atoms, in my case, it goes to 29, which is of copper. It has only 1 electron in s orbital. For some other cases, for example, like 43 or whatever cases in your number, maybe iron of 26. So you can find that the number of atoms that present in the suborbitals also too. So those electrons, those free electrons that present in those suborbitals are the cases for oxidation number. Hope this might be little more bit information to you, and stay tuned for part 2 where we discuss more about in it.